Hello and welcome to this BioProcess International Ask the Expert webcast. I'm your host, Leah Rosen, the online editor for BioProcess International. Before we get started, just a couple of notes. This webcast is being recorded and will be made available for replay in the multimedia section of our website. We've muted the audio lines, but we welcome you to type in your questions for our speakers in the question and answer window on your screen. After the presentation, we will begin the question and answer portion, and I will ask our speakers your questions. Your questions in the question and answer window will only be visible to myself and our speakers. So thank you for joining us today. It is now my pleasure to introduce our speakers, Jenny Dunker and Alex Troken from Cytiva.
Hello all, welcome to our webinar. My name is Alexander Troken, Global Product Manager for Process Liquids and Buffers working for Cytiva Life Sciences. Jenny Dunker, Global Product Manager for Customized BioProcess Solutions, and I will be using this webinar to present how to increase efficiency in your manufacturing with the right buffer management strategy. In this presentation, we'll cover the following points. First, we'll cover the current landscape around buffer management and how, throughout the recent few years, it is emerging as a bottleneck in biopharma manufacturing. We'll then talk through different approaches one can take in intensifying buffer management and advantages and disadvantages associated with those different options. And then we'll talk through an evaluation of different buffer management strategies using a typical 3-step MAB manufacturing process, and end on an understanding the sweet spots around which buffer manufacturing approach might fit within your internal strategy, and which items to consider in selecting this sweet spot. Before we get into the meat of this webinar, we'd like to highlight this quote from market research that was conducted on behalf of Cytiva that is very relevant. Success begins and ends with the quality of a buffer. Better to reject a bad buffer than risk a batch failure that could cost millions. Buffers, often neglected within a bioprocessing system due to their simple formulations and generally non-glamorous nature, are just as imperative as any other step that would shape the success of your process. Buffer management is a bottleneck in biopharma. Please see this graphic that indicates the conclusion from a collaborative study that was conducted in 2018. 7 out of the 10 downstream equipment types with the longest occupancy duration are buffer related. What this means is that buffers take time, a lot of time from your processes. As one scales up, this sort of factor will impact your throughput, and as volumes increase, start impacting other areas within your organization, be it warehousing, space, staffing, etc. And this is illustrated when seeing the trends that were verified in internal market research, as well as in the annual biomanufacturing report from BioPlan. The BioPlan report is a thorough one as it encompasses different geographies with respondents from 33 different countries, different levels, different customer types, from startups to large-scale industrial to CMO. But irrespective of these distinctions, approximately a quarter of respondents called out buffer-related items as being a root cause constraint on their capacity. Internal research further categorized where this pain was coming from: footprint, time, and scalability. Lastly, 41% indicated pinpointed hardware-related technology, such as inline dilution, as a viable way to combat this bottleneck. Jenny will dive a bit deeper about both this as well as inline conditioning and how they could stack up to help you resolve your buffer management issues.
Thank you, Alex. So, intensifying buffer management, what are the options? Usually we talk about 4 different options. Manual preparation being the traditional way of making buffers, where you mix your powder with water. Inline dilution, which has been around for some time, where you reduce the volumes by concentrating your buffer and then diluting with water. Inline conditioning being the next level, where you split your buffer into its individual components, its acid, base, and salt, and then let the system blend your buffer at the point of need. And finally, outsourcing, either your pre-made buffers or concentrates for inline dilution or for inline conditioning. Before we move on, let's take a closer look at inline conditioning. So as I said, this is taking inline dilution to the next level. Here you split your buffer into its individual components, its acid, base, and salt. The benefit with this is that you can reuse several of these stock solutions for a range of different buffers. Maybe you have different phosphate buffers with different pH and concentrations, and you can use the same set of stock solutions to prepare all of these, which will reduce the number of solutions you need to prepare up front. In addition, each solution will only require the mixing of one chemical component with water, which is much more simple than making a buffer. The inline conditioning system can either be used as a chromatography system that is connected directly to a chromatography column, or you can use it to deliver buffers into tanks and bags like a buffer kitchen. So let's look at the advantages and challenges with all of these different options. When we look at manual preparation, the big advantage is, of course, its established way of working. Everyone knows how it's done. The challenge is all around the buffer bottleneck. It's labor intensive and time consuming. It occupies a large percentage of facility footprint, and it's difficult to scale up. Let's look at the other options. So for inline dilution, the advantages is, of course, that you can reduce the floor space and tank volumes by concentrating your buffer and diluting, and it will also do savings in labor. But the challenge is that you need to handle pH shifts due to dilution, and you will also need some kind of capex investment of an inline dilution skid, which is a little bit more than if you're just preparing buffers manually. Inline conditioning has similar advantages as inline dilution, but here you can reduce the floor space and tank volumes even further, since you can reuse the same number of stock solutions for several buffers, and this will also do significant savings in labor. Then, since you have these more sophisticated algorithms to prepare your buffers, you will have a higher quality control of your buffers as well. The challenge here on the other hand is that the capex investment can be perceived as high, and it's not suitable for complex buffers with many components, and the technology is still evolving. When it comes to outsourcing, the advantage is, of course, that you get immediate capacity relief, and this will reduce labor time and reduce the facility footprint needed for buffer preparation significantly. The challenge is that you will need to set up the supplier qualification and specifications, and also secure the security of supplies, that you get the buffers when you need them. And then you should also need to consider any kind of IP protection, that you will be giving away the buffer recipe to a third party. So to sum up, I believe this quote exemplifies the buffer challenge in a good way. At the smaller scales, buffers are not a big problem, but as scale goes up, buffer volumes increase, and you need to prepare this in advance. So what the quote says is, when we transfer the process to manufacturing, it should not happen that we need to prepare thousands and thousands of liters of buffers and then question ourselves, where do we store them? Now I will hand over to Alex, who will continue and show some data from the simulations that we have done.
Evaluating buffer management strategies using a typical 3-step MAB manufacturing process. The Cytiva has a broad portfolio that can be offered to help address buffer management issues. We thought it valuable to run simulations under a number of assumptions, of course, and to evaluate the outcomes of these simulations around specific key performance indicators, namely space, time, and cost. It's understood that there is no one-size-fits-all approach in buffer management, and that every situation will have a number of factors that's contributing to how buffers are managed within a facility. But that said, it's worth looking at because the results of the simulation were quite compelling. The different strategies that were evaluated were traditional buffer preparation, outsourcing of 1x buffers, and also variants of inline conditioning, IC for short, and inline dilution, or ILD. Was run under a simulation of a 3-step MAB manufacturing process at scales requiring volumes of 400, 4,000, and 15,000 liters of buffers. Here we have a more detailed view of the different approaches that were taken for this simulation. Workflow A is the traditional buffer manufacturing approach. One can see that the overall process was taken in the following buckets. The first one was upon receiving the individual chemical components as raw materials. The primary preparation would be formulating, weighing the buffers, mixing and titrating the buffers. And then there is a hold area where the buffer is fully prepared and ready to use. And eventually it is used within the chromatography system. Workflow B is where the buffers are outsourced, allowing pre-made buffers to come to your facility ready to use. Workflows C and D are inline dilution related. Workflow C is when the concentrated buffers are still prepared internally. And workflow D is when the concentrated buffers are also outsourced and arrive in your facility ready to use. And workflows E and F are inline conditioning related, with the differences between the approaches also being single component concentrate solutions prepared in-house, E, versus outsourced and arriving ready to use, F. Note that it's noted that preparation of single component solutions while using an inline conditioning system for multiple batches can strengthen or intensify these workflows even further. In evaluating those KPIs, space, time, and cost, the results were rather persuasive when scaling the buffers up linearly at the simulated MAB manufacturing scales. One can see here that at the 15,000 liter volume, space could become a very large issue, particularly within your operating facility. The red arrows indicate that as outsourced items don't require a buffer kitchen, this space constraint can be alleviated by outsourcing either 1x buffers, buffer concentrates, or single component stock concentrates. The difference between the IC and ILD would be due to the differences in the system size. This slide shows a comparison of the volumes being moved around for the 15,000 liter simulation when space would likely start being considered an issue at the scale. Here, it shows a case being made for hardware-based buffer management strategies. Further to this, at these volumes, inline conditioning coupled with outsourced single component stock concentrates seem to reduce the volumes of liquid being moved around the most. Note that an assumption was made here that any outsourced liquids, be it 1x or concentrated solutions, would be transferred from the warehouse into the process suite. And that is why there is no primary preparation or primary hold indicated in those bars. The second KPI is time. Here is the bar graph indicating the sum of the total hours needed to prepare buffers for a batch at the 15,000 liter scale. Of course, assumptions need to be made in terms of time needed for receiving an inspection, formulation, weighing, QC testing, etc. But that said, the results also indicated a relatively clear tendency that at that scale, outsourcing pre-made, ready-to-use solutions are incredible time savers. If, however, the internal strategy is to maintain internal manufacturing of liquid solutions, inline conditioning was the most efficient with regards to time. This slide indicates the cost of labor for buffer production at the 15,000 liter simulation. It also illustrated that the production of the buffers themselves and quality control of them are the main cost drivers related to labor. For manual preparation, labor cost is significantly reduced when choosing an option including IC.
So now we've considered how different buffer management solutions impact space, time, and cost. Let us continue and deep dive into the cost perspective. So on this slide, you can see the operational costs per year for different options at two different scales. 400 liters of buffers in green and 15,000 of liters of buffers in blue. The operational costs covers everything except for the capex. At the left, you have the cost for the traditional way of producing buffers, workflow A. Interesting to see is that all other options demonstrate a lower operational cost at both scales for this example. Let's look at the different workflows. So you can see that outsourcing 1x buffers, workflow B, is most cost efficient at the lower scale if you compare the green with the blue bar. Moving to the right on the graph, you have the inline conditioning inline dilution alternative. And you can see as scale goes up, inline conditioning and inline dilution proves to be cost-efficient solutions. If you choose to outsource the concentrate for inline dilution or the stock solution for inline conditioning, the operational costs are equivalent. If you instead want to prepare your concentrate or stock solutions internally or manually at your site, then inline conditioning is proven to be more cost efficient. This you can see if you compare workflow E with workflow C. And this is driven by the fact that it requires less time and labor to prepare a single component stock solution as compared to buffer concentrates, for example, less QC work. Let's take a look at the cumulative cost comparison. So in this data, compared to the previous slide, we've added the CapEx. Again, we show data from 400 liters of buffer to the left and 15,000 liters of buffer to the right. And the different colors of the lines represent the different workflows, gray being the manual way of producing buffers. Similar trends can be seen as in the previous slides. Outsourcing buffers is a good alternative at the lower scale. When you move up in scale, inline conditioning and inline dilution are the most cost-efficient ones. And if you want to prepare your stock concentrates or stock solutions in your own way, inline conditioning is the best option. And interesting is to also take a look at the ROI, the return on investment. You can see that for all the workflows, this is reached within the first 2 years. So even if you require some CapEx investment, you will still reach a good cost efficiency over time. So to summarize the impact on the key performance indicators, we have been looking at space. So here, outsourcing buffers or concentrates for inline conditioning, inline dilution will minimize footprint in buffer kitchen. And if you want to optimize the volumes that you're actually handling and moving around at the facility, inline conditioning will be the most efficient alternative. For time, outsourcing again is the best option. If you want to do something manually, internally, then inline conditioning will save most time in the buffer prep area. If we look at cost, CapEx is driven by hardware, where inline conditioning being the most expensive, and OpEx is driven by labor time and consumable cost. Also do remember that we used a conservative process that converted 12 buffers to 10 stock solutions. So for other processes, or if you consider several processes at the same time, difference between, for example, inline conditioning and inline dilution might be higher. So now we've looked at the data for the simulations and how these affect space, cost, and time. Let us continue and look at some other perspectives that are also important to consider when choosing buffer management strategy. Starting with technology, inline conditioning and inline dilution showed similar savings when outsourcing your concentrates and stock solutions in this particular example. So what are the other considerations you should make? So on this slide, I just wanted to recap the difference in buffer making capabilities between the two options. So as we have been mentioning, one main difference is the possibility to reuse the same set of stock solutions for several buffers, but also the more sophisticated control modes that will ensure that the buffers are made to specification and ensure the quality of the buffers is important to remember. And to exemplify this, here we show some application data where we've used inline conditioning to prepare a specific buffer with a pH target and a conductivity target. So what you see on the screen is data from several buffers that were mixed using a range of stock solutions, where we have introduced a slight error into some of these stock solutions to see how the system can compensate for these variations. Then we ran the system or prepared using the 3 different levels of control modes. The first being flow feedback, where you basically enter a percentage for each pump, which is similar to inline dilution. The next level is adding the pH feedback, and then the third is the pH and conductivity feedback. So what you can see here then on the result is that in the first part of the curve where we used flow feedback, there was no compensation for the errors in the incoming stock solutions. So the data is quite scattered. If we then add pH feedback, you see that there's a nice pH adjustment to reach the pH target for all the different curves, regardless of the incoming stock solutions, but the connectivity is still scattered. And then in the last part, we add the connectivity feedback, and here again, we reach the connectivity target for all the different curves. So it's really highlighting how the system can ensure good quality buffers regardless of the incoming stock solutions. Now I will hand over to Alex, who will continue to talk about.
Thank you, Jenny. This slide indicates items to consider when taking an approach that has to do with outsourcing 1x buffers. In those earlier phases, when one might not be comfortable enough with their processes, or further evaluation needs to be done, or clinical product needs to be manufactured, or your plant is simply full with other projects, prior to a large CapEx investment, outsourcing 1x buffers would be a very practical approach to take. Here's a more clarified look at some of the advantages that this route would encompass. It would allow flexibility to fit your facility footprint. Buffer variability would be minimized if the process is not yet locked down. If the capacity constraints is your issue, outsourcing 1x buffers might be a way to achieve capacity relief and allow resources to be used elsewhere. Having a single supplier to qualify would reduce audit burden on your quality or supplier quality staff. Lastly, time-consuming cleaning and validation activities could be mitigated. Applying single-use technologies and having a plug-and-play approach would greatly improve cycle times, maximizing throughput in your facility. All of this being said, as stated earlier in this presentation, there is no one-size-fits-all scenario. And that being said, we're willing to work with you as you determine what the primary drivers at your site might be it space reduction, minimizing labor time, cost efficiency, etc., and supporting you to come to an effective outcome. These simulations also helped us, as well as indicating how outsourcing or using an automated hardware approach, such as inline conditioning or ILD, can achieve these. And that said, on the right-hand side of this slide, there might be an uncertainty in changing gears for buffer management, of course. It's understood that manual preparation in your house is the tried and true method that you might feel comfortable with within your processes. However, once commercial manufacturing takes hold and these processes are scaled for their masses, so to speak, issues might be a consequence from this scale up. And we want to help you resolve those issues. Look at this quote from the market research. This customer needs 40 types of buffers. Those are 40 different productions, 40 buffer batch records, QC tests, etc. And via the IC solution, they could reduce that volume to 6 to 8 single component stock solutions. This is quite staggering when thinking about the costs associated with each of those buffer productions and the savings that can be achieved when implementing the new approaches. So let's start that conversation. Cytiva has hardware that can take you through different scales as your batches go larger and you move into a GMP environment. And consumable options that would also allow the scale up to be as effective as possible. From small bottles to large bottles, to bags to large bags, to many large bags. At some point in time, as depicted here, many large bags may have issues associated with them. Here, you can imagine space might be an issue, be it warehouse or cleanroom space. So we would then move into the inline conditioning or inline dilution approach and use concentrated buffers with them. We'd like to join and support you on this journey as you transition your buffer management. Thank you very much for your attention. I hope that you learned from this webinar and found it as valuable as we did in putting it together.
Okay, great. So the first question is for Alex. When outsourcing buffers, how can you ensure the right buffer quality?
Can you hear me?
Yes.
Okay, good. Thank you. Yeah, this is a really great question, and I alluded to it in my presentation that one thing that we're really proud about is the very effective customization process within the high clone buffers business. So if a customer were to not find the standard products sufficient for their needs, be it an extra pH testing or a certain pH level or osmo or conductivity or what have you, it would be helpful for the customer to come up with their critical quality needs. And then, of course, have a conversation with us, as I had mentioned in the presentation, have the conversation to ensure that what they need is something that can be provided. And, of course, we'll discuss.
Okay. And for Jenny, what do you see as the biggest difference between ILD and IC?
So I think one major thing, the biggest difference is really the flexibility and quality in making buffers. So with inline conditioning, you have more sophisticated controls. You have more ability to adjust according to the buffer you're making. So you can take into account variations like if you're doing a weak interaction or a weak strong interaction and those kind of things. So you can really adjust the buffer in line when it's being done, so to make sure you get the specification according to the needs that you have. And this would then compensate for any temperature variations or stock solution variation as we showed in the data. So that's one thing. And then the other aspect is really this with that you are using single stock components for inline conditioning, which you can reuse for many buffers. So you get this possibility to get some kind of economy of scales that you can have a set of library of stock solutions that you reuse for all your buffers. So that's quite an efficient way to set up your buffer making capabilities, I would say.
Okay, and for Alex, what are your thoughts on using osmolality alongside pH and conductivity, which can be sensitive to temperature, for example, to verify buffer quality?
This is a really great question, and I appreciate you asking that. Again, I have to highlight the customization process again. My thoughts are that if there is a certain temperature range with which you want the buffer produced in and kept at and stored in, then highlight that, of course. Certainly in-process testing is something that needs to be taken into account as well as release criteria. And something else that's quite often, I think, overlooked is the overall stability and shelf life, especially of a custom buffer. So something else that the high clone business offers is a custom stability program. So as when you go through the customization process, you can also set up a stability study in the beginning to also be able to assign the shelf life and a potential expiry date for these custom buffers. So again, it would be what the customer would want, and then meeting somewhere to being able to deliver.
And Jenny, is your ILC ILD skid single use?
No, so the skids, or I would say for the inline conditioning, we don't have single use. They are reuse or made of stainless steel and polypropylene. When it comes to our inline dilution skids, those are basically our standard BioProcess systems, which are stainless steel. But then we also have our single use variants, the Ecta Ready and the Ecta Ready XL, and those are single use and can be used as inline dilution skids.
Okay, and I have another question for Jenny. For the different scenarios presented, what are your assumptions regarding the Wi-Fi supply, an internal loop or versus outsource?
Do you remember that, Alex? The water is a really important part to that you need to have a continuous supply of the water continuously. So I don't think we specified exactly how the water at that level, where the water came from, but more that, I mean, you need to ensure that you have a continuous supply of water, since you will be using a lot of water when you're preparing the buffer in line, of course.
Correct. And I think for the simulations, the assumption was that the customer had a WFI infrastructure, so it wasn't outsourced water. But we can double check to ensure. Mm-hmm.
Okay, great. And this is for Alex, what are Cytiva typical lead times for manufacturing liquids? Are there differences between concentrates versus 1X?
In terms of the lead times, there are, okay, let's start with the second question. Currently, there are not differences of lead times between for concentrates versus 1X buffers. That being said, I think it goes without saying we're all in a very, very unique situation in terms of the demand. So, of course, that is pressing the lead times a little bit longer than what we'd like to. But what we can also be saying is that Cytiva, certainly the high column business, I'd like to say Cytiva all the way around, and I think the industry as a whole is undergoing capacity expansion, with which I certainly have never seen within my career. And I can definitely say within Cytiva and within high clone, the capacity expansion is moving at a pace which is truly unprecedented. In terms of typical lead times for manufacturing liquids, it is completely dependent on the prioritization, the use, and the customer.
Okay, and this one is for Jenny. What is the trend for customers when adopting ILD, ILC, and do they go all in immediately, or do some tend to keep a certain critical buffers, like excipient solution buffers, as manual preps to begin with from a risk point of view?
That's a really good question. I think this is all very different at different customer sites, but I think in general, we all know that the industry is quite conservative. So most of our customers, I would say, are taking it at steps. So when first they kind of evaluate the different technologies and make sure that the buffers are made according to, in the same way and get to the same quality as when they've done them manually. But then maybe they start with making the buffers which are not, not used during the load, or those kind of minor differences, that they do the simple buffers first. And then as they feel that the buffer that are not as critical in the process when you're eluting your product, and then as you feel more confident, you start adding the other buffers and so on. So I think it's a journey, and different customers do it at different paces. But it's a good question.
So for Alex, you indicated Cytiva is willing to accompany through transition from small scale to large scale. What are the minimum volumes you're willing to manufacture?
From the custom buffer business, 100 liters is what we usually start out, so the minimum volume. But that's all, of course, dependent on the annual demand and how much they might need over the course of a longer period of time. But I would say if you want something set in stone, I would say the beginning for the minimum volumes would be 100 liters.
Okay.
As with anything else, that's dependent. So there are other aspects to take into consideration. But small scale to large scale, that would be it. Mm-hmm. And and of course, going smaller than a smaller scale, of course, we have bottled products as well. Sorry, Leo, please continue.
No problem. I want to make sure you get all the answer.
Mm-hmm.
I know these are real answers in real time. So, Jenny, does your cost model include a Wi-Fi loop or outsource Wi-Fi?
So I'll have to come back on that one. I don't remember exactly what we included in the calculation. If you don't remember, Alex.
We'll come back to you.
Yeah.
We'll come back to you.
Okay. And then Alex, can you let me know the general timeline for standard buffers and custom buffers?
there are separate buckets on this answer. So the standard buffers, there are standard buffers that are made to stock. So the stocking strategy clearly has a lot to do with it. And with anything else, of course, the ongoing demand, we're giving our supply chain pressure that we haven't provided before, for sure. So there's the made to stock items that are meant to be on the shelf with less than a week, hopefully just a few day lead time. There are standard buffers that are made to order, so they're not ordered as often, or the demand is not yet there, but there is a standard portfolio of made to order items. Those made to order items is of course dependent as how often we are manufacturing the made to stock items, and sometimes those made to order items could also be fit within there. So of course we're trying to manufacture as effectively and as cleverly as possible. And the custom buffers, with all due respect, it depends. It just completely depends in terms of the level of customization that the customer is looking for. So if it's a simple customization on a bag, maybe a tube is a little bit longer than something from our standard bags, or if it's a new release criteria that we can do in-house, the lead time, of course, would be a little bit shorter. If it's something that we would need to search externally, or there's a very specific raw component from a supplier that we haven't yet qualified, these sorts of items, then that customization, of course, becomes a little bit more difficult, and thereby extending the lead time a little bit longer. So the general lead time, it depends whether the stocking strategy is made to stock, made to order, and the level of customization.
Okay, and it looks like we have, let's see, here's a question for Jenny. The IC technology seems quite complicated to use. What is your view on that?
So I think at a first glance, it might look a little bit more complex, but it's really quite similar to a chromatography skid, just adding a few more pumps, basically, or a few more components. So from a maintenance perspective, it's quite similar to how you handle your chromatography skids today. And when it comes to buffer making, if you have full control over and understand how you make buffers, you know the variations around making a buffer based on a strong corresponding acid and base versus titrating with a strong acid or base, and those minor things, then you will understand the control modes. Also, if you are well into chromatography and inline dilution, and you know that the pump specification will affect the volumes that you're able to introduce into the system, then you will also understand the kind of limitations that the pumps are affecting on this. So I think at a first glance, as I said, it might seem complicated, but when you start peeling it down, it's not. You will get a grip, and we will of course help you on this transition journey as well. So that's what I would say.
Okay. And for Alex, outsourcing is convenient, but it also means that you need to rely on your supplier. What is your view on that?
That's a great question, and an important one. And something that probably should be mentioned is the fact that we have a very robust security of supply system within Cytiva. The assumption, of course, is that our customers also have a supplier qualification. And as I had alluded to in the presentation, you're probably qualifying a number of suppliers for your raw materials for your buffers. And if you were to outsource your buffers, then those qualifications would end up going to one qualified supplier, that being Cytiva HiClone. And we would take on that burden, the audit burden, in terms of qualifying our suppliers based on what we consider critical for our quality. So yes, it is convenient. There is a lot of background work, of course, that needs to be done. And we are definitely dependent on our supplier as a partner. So, of of course, we depend on our supplier as a partner with us, just as we, of course, would like to be a partner with our customers on their buffer management journey. So, yeah, it's an important factor.
Okay, so it looks like we have time for just a couple more questions. I think I have one question for each of you, but if you haven't, if we don't get to your question, we will have Alex and Jenny follow up with you, and just go ahead and continue to enter questions, and we'll be able to pass them on. So Jenny, most of the buffers are filtered after preparation. What do you think about filtration for IL preparation?
So what did you say in the end there? I missed it. So what do you think about filtration for... Oh, could you repeat the question? Sorry, I didn't... Now you're muted.
Muted.
Yeah.
Most buffers are filtered after preparation. What do you think about filtration for IL preparation?
Okay, so this is also an important question. So it's also a little bit depending on the setup at the customer side, how they do. Some filtrate, make sure that the stock solutions that are connected to the inline conditioning skid are filtrated, and then rely on that. And then you also have the opportunity or the option to have inline filters on the icy skid. So there's a lot of different variants of that. So I think it's something that we would need to discuss kind of each individual case, I would say.
And can I just interject and highlight something there, if you don't mind? And Jenny, you're bringing up a really great point. This whole exercise in terms of simulation was really driving home the fact that there is no one-size-fits-all scenario, and the whole buffer management world is something very unique. And as we're all learning, customers handle it differently based on a number of factors. That's also tied into their own internal strategy, as we highlighted in the presentation. So. Yeah, we'd be happy to take on that conversation.
Okay, and I think the last question then is for you, Alex. Are there any available compatibility data included for leachables and extractables with highly concentrated buffers in single-use bags?
It is dependent on what would be considered, what would be defined as a highly concentrated buffer. And the film used, of course, within that single-use bag. So sometimes it's dependent as to which specific buffer, which specific bag, if it's established on the market. If we've done an internal R&D test in terms of extractables, leachables, Cytiva has a very good extractables, leachables extractables, leachables laboratory based in Uppsala, Sweden, that can help execute this as well, if there's a very unique buffer. But there is generally some E&L data, but it would be dependent in terms of which buffer.
Well, thank you, Alex and Jenny.
Thank you very much for listening.
Thank you very much.
Thank you to our audience for joining us. The recorded version of this webcast will be available on demand for viewing on our website. As a registered attendee, you'll receive a follow-up email providing you with a direct link. We look forward to having you join us at future BioProcess International Ask the Expert webcasts. Look for those announcements in your inbox. Goodbye.
Thank you.
Thank you. Bye-bye.